All right, today we're talking about section 1.1, functions. Let's go to work. We're going to start today off with a quote. Today's quote is, "A short pencil is better than a long memory." A short pencil is better than a long memory. I got that from Alton Hill. Alton Hill was a guy I worked Clemson basketball camps with for years. He was a good bit older than me. He played high school basketball at Virginia Beach High School in the 70s, and they went almost 3 years without losing a game. They won consecutive state championships and have one of the longest winning streaks by a high school basketball team in the country. They won like 98 games in a row. It was impressive. Alton was like 6'8", heck of a ball player. But he said this to me multiple times: a short pencil is better than a long memory. What it means is it's better for you to have a short pencil so that you can write things down than to just try to remember it. And that's what I want you to do in this class throughout the year. I want you to write things down. If you rely on your memory, I promise you, it won't be as effective, okay? So write things down. I want to be so specific that if I take the time to write something down like I have here, it's very important that you take the time to write it down as well. Can I get an amen? All right. So let's start with today. Hopefully from your reading last night, one of the first things you got that a function is with a function. I'm going to change this up a little bit. The true definition said, for every input, there's exactly one output. For every input, there's exactly one output. Let's shorten that down just a little bit and say each input has one output. Now, we're in math class, Algebra 1, and a lot of times we think of math and you think numbers, right? One thing I wanted to get across to you early this year is that Algebra 1, people start getting or having difficulties because we really stop using numbers and really start using letters and variables a ton because we want to see how things work for everything. And that's what a lot of people start having difficulties, okay? What I want you to understand is math is a lot more than just number computation, calculations. It's a lot more than that. Math is problem solving, logic, and reasoning. Okay? So we're going to have problems. So, for example, there are going to be things that I'm going to be able to give you and I'm going to be able to ask, is that a function? And it ain't going to have any numbers really involved in it. Okay? For example, if I said, hey, the input is all the people in this classroom, I'm going to ask each of you a question. Okay? I'm going to ask each of you a question. What's the input? Each of you, right? And the question I'm going to ask you is, what's your birthday? Is that a function?
No.
No? Why is it not a function, Darren?
Because every person don't have the same birthday.
Okay. But I'm going to ask you, what's your birthday? What's your birthday?
May 19th, 2007.
Is that your only birthday?
Yeah.
You don't have another birthday?
No.
Does anybody have another birthday? Everybody only has one birthday. What's the input? Each of you. How many outputs are there for each of you?
One.
So is it a function?
Yeah.
Yes, because each input has exactly one output. Yes?
Yeah.
Here's another one. Tell me whether it's a function or not. A person's age and how much money they make. Age and how much money you can make. So what are the inputs? People's age. So from like 0 to
100.
100.
30.
Okay, so your domain or your inputs are 0 to like 100. Could be a little bit more, right? What's your output? How much money they make. So let's think about the age. I don't know. How old are you guys? 14, 15? Let's say think 14. So does every 14-year-old make the same amount of money? So is it a function? No. We're not even using numbers really, right? But it is mathematical and it is a function. All right. What is a function? Each input has exactly one output. Yep. All right. I got another one. Just one more. Your door, your front door at your house, the lock on the front door of your house. Okay. The lock and the number of keys it has. If your lock's the input and keys that'll open it is the output, is that a function? Yeah? Really? Why not? You got more than one key, don't you? So is it a function?
No.
Now, you might argue, Jared, but there's only like one key that are open. Like other keys won't, but I can have multiple copies of that key. So is it a function? No. No. Cool. What is a function? Each input, one output. All right. So I gave you a lot of different examples that weren't mathematical. Okay, we'll come back to that. Next thing we're going to talk about is function notation. Function notation. Function notation is just where we're going to use f of x instead of y. We're going to use f of x instead of y. Let me give you an example. Way back when you had y equals x plus 2. That looked normal to you? And then along came a teacher or somebody said, hey, x equals 3. What would you do with that 3? You'd plug it in. So you'd say y equals 3 plus 2 or 5. Yeah? Okay. Well, the only thing that we want to do different, instead of using this y, we want to say, hey, f of x equals x plus 2. So we just replaced the y with an f of x. That's it. That's all function notation is. Okay? Then instead of writing x plus 3, we would say, hey, if we did the function with an input of 3, what would we get? And everything else is just the same. 3 plus 2, which is 5. That is function notation. So I'm telling you, anytime that you want, you can replace f of x with y, or you can replace y with f of x. They are exactly the same thing. It's just that when we use f of x, we call that function notation. Now, I will say we could also use g of x, or h of x, or m of x. Really doesn't matter what letters there in front of it. Those are just different types of function notation. You guys okay with that? F of x. I say f of x, you say y. F of x.
Y.
F of x.
Y.
I say y, you say f of x. Y. Y. Yeah, this could be like a song. Okay. Next, evaluating functions. When it comes to evaluating functions, all we need to do is plug the value in for the variable. Now, in all honesty, I just did that twice for you up here. I don't want to show you again. A lot of times when we're evaluating functions, we'll evaluate it for several numbers. For example, I have this function for you here, f of x equals x plus 1, yes? So if I were to evaluate it for all of these inputs in this t-chart, matter of fact, I call that a lazy t-chart. Does anybody know why we call it lazy t-chart? Because it's laying down. Don't worry, I'll be here all week. All right, so f of 0 means we just plug the 0 in for the x. 0 plus 1 is 1. And then we put that into the t-chart. So we just evaluated the function at 0. Let's evaluate the function at 1. What does evaluate mean? Plug it in, plug it in. Nice place for Mary Niller plug-ins right there. So 1 plus 1 is 2. F of 2. We're going to evaluate the function at 2. That just means we're going to plug 2 in for the variable. 2 plus 1 is 3. So on and so forth. Is that enough? Yes. Enough? Okay. Let's evaluate the second one. I don't want to do 0, 1, and 2. I want to do 1, 2, and 3. Let's evaluate the second one at 1, 2, and 3. So evaluate just means plug it in, plug it in. So we got 1 squared plus 3. 1 squared is 1, plus 3 is 4, right? Let's evaluate it for 2. Find f of 2.
We hit a bad thing.
We sure did. 2 squared. Let me finish this little bit and I'll pause. 2 squared is 4. 4 plus 3 is 7. Sorry about that. Let's try. Is it back yet? It's not back. It says it is. All right, sorry about that little hiccup. Let's back to it. Domain is all the possible inputs for a function, and range is all the possible outputs of a function. So I want you to remember the fact that input is also the x value, also known, and then output is also the y value. The input and the x value is also known as the independent variable, and therefore the y value is also known as the dependent variable. And here's where a lot of people get mixed up or don't continue the trend. And the input, the x value, the independent variable is also known as the domain, where the output, the y variable, and the dependent variable is also known as the range. So when it comes to domain and range, all you got to think of is all the things that can possibly go into it, into a function is the domain, and all the things that possibly come out of it are or is the range. For example, let's think about a microwave. What can you put into a microwave? What is the domain of a microwave? Well, you can put pretty much any food that you want into it, right? Pizza, but what can't you put in? Well, you can't put in any metal. There's certain bowls that you can't put in, and there's certain plates that you can't put in. You can't put any metal into a microwave or it'll cause a fire. So the domain would be all types of food and microwavable plates. Okay. And then range is all the possible outputs of something. So for now, I just want you to realize that input and domain, those two words are pretty much interchangeable. Output and range, those two are pretty much interchangeable. The next thing in there that I did not talk about with y'all is the vertical line test. The vertical line test is anytime that we're given a graph, okay? Anytime we're given a graph, if we were to put a vertical line, and I like the way your reading said, if you were to take a pencil and put it vertical over top of that graph anywhere, as long as it only touches it once, if it touches one touch, it's a function. But if it ever touches that vertical line at any spot more than once, it's not a function. For example, this one would not be a function because that vertical line is touched more than once. This would not be a function because that vertical line would be touched more than once. This would be a function, but if I add one more value right there, it's no longer a function. So that's a vertical line test. I think the vertical line test is one of the easiest ways. If you have a graph, put a vertical line over it, and as long as it never touches it more than once, you have a function. If it ever touches it more than once, it's not a function. So your homework tonight is 1, 1, 2 through 46, even. Make sure you check your answers using the even work problems video on the Algebra 1 curriculum timeline. Have a great day.